Okay, welcome back to the next part of the video. In the last video, we brought the XR2 from the point where we were just a few hours away from Earth all the way over here to our closest approach at Venus. And the point between the ejection burn at Earth and getting over here to Venus, we completed a total of 4 mid-course corrections. And let's do a brief recap on what those were. When we got out away from Earth far enough to where, its gravitational influence dropped to nearly 0.00 and the transect stage is updated, had the first mid-course correction of 22.53 meters per second. Actually, I take that back. That's not actually when I did that mid-course correction. That's when I used to always do the first mid-course correction, but I found through talking to Dimitri, that it's actually better if you skip that point and continue going on until your closest approach to Venus. According to what you see in transects, you'll see that number start to count down, and once that number gets as low as it will get, that is actually a better time to do that mid-course correction. So that's when I did the first mid-course correction. And again, that was 22.53 meters a second. And then as we leave that point and go forward, it's better to, the better time to do the mid-course corrections, general rule of thumb, is every time the distance has been cut in half one time. So that's what we did. And on the second mid-course correction, it was 1.09 meters a second. So almost nothing, just a little bit of translation to nudge the vessel a little bit one way or the other. And then a second mid-course correction of 0.8, and finally a third mid-course correction of 1.08. So those last three were just to nudge the vessel to keep it on track, with the relative inclination and the PE ratio. So we are here now at Venus, and we've got more than half of the journey still to go in terms of time, because we ended up coming around the sun and catching Venus more over, on the, you kind of orbit the sun counterclockwise, and we caught it more over on the 9 o'clock, 8 o'clock side, somewhere over there. So we still have to go all the way back around the other way, and I believe we've got something like 300 days still ahead of us, somewhere around there. And if we take a look, let me bring up the other MFDs because they're bigger. If we take a look at our burn time calculator, we can see that we still have a total of 409.7 meters per second of delta V available to us. And this number, interestingly enough, will actually go up as we go forward. At least it'll go up for a while until we need to do another burn. And the reason it goes up is because we're burning LOX, or we're using LOX. And as we use LOX, then our vehicle mass decreases, so we actually gain dV as we move forward. And that's not the total. If we include the 691.5 of RCS, then we've actually got a total of 804. So this is actually plenty of dV, believe it or not. It's actually way more than we need. But let's go forward. We have done our closest approach at Venus, and as I explained in the last video, I think it's interesting, how you come to these points, and it takes a long time to get there, and then the moment that you cross periapsis, every second that goes by after that, you're getting farther and farther away. There's no time to really hang out and enjoy the scenery or anything. It's just there one moment and you go on the next, basically. But now we have to ask ourselves when we want to do the next mid-course correction. And I actually want to show, kind of like I did the first time where we stopped, when we left Earth and the gravitational influence of Earth got down to 0.00 and the stage is updated, and I stopped momentarily just to see what it would cost to do a mid-course correction at that point, and the number I came up with was 53.15, and then by warping time forward we were able to cut that cost in more than in half. So I want to do the same thing here as I'm on my way back to Earth. I just want to show just how much we can save, and it's a huge amount going back the other way. We didn't really save a ton on the Earth to Venus sling, but as we leave Venus and go back to Earth, you're going to see that if we don't do the mid-course corrections at very specific times, then it could cost us a fortune. In fact, we wouldn't even, if we did it really bad, we wouldn't even have enough DV to get back. So that's kind of what I want to show.
Translation. Rotation.
Let's go to rotation here and kill rotate, and let's warp forward. And what we'll do is we'll go forward until, you know, Venus gets to 0, 0, 0 on its gravitational influence, which means we're far enough away, you know, that it is no longer really affecting our vessel too much. And then we'll see what a mid-course correction would cost at that time, and it won't be cheap. And it's good to know, because that's usually when I would think, when, you know, in the past, that's when I always thought that's the right time to do the MCC. And I didn't come up with that on my own, by the way. It's actually in the Deep Space Manual that's comes with Transx. It actually specifically says that that's the right time, but it simply isn't right. So we'll see here, this will get to 0, 0, 1, and then our stages update. So let's immediately go back to real time, and let's set up a maneuver, and let's just see what it would cost. As always, we'll go forward on this side to view the encounter, and we'll set up the maneuver on this side. So maneuver mode on, and we'll just start plugging in some variables here to see what helps us. Okay, adding in positive prograde, that's raising the closest approach. It's not what we want. So a little bit of negative prograde. And you can see that closest approach is coming down. And I'm not going to fiddle with this too much since we're not going to use this. So let me just get it reasonably close, and then we'll say it's good enough. So there's our prograde. And we probably need a little bit of plane change as well if we want to bring it all the way down. Yeah, we'll go with that. Actually, that gets us all the way there anyway. So let's consider what we have here. Let me make a note of it for future reference. So we have a total cost of 53 meters a second. That's not too bad, actually. It's 5372. And this is when, let me just, Venus equals 0, 0, 0 G. So if we were to do our first mid-course correction at this point, this is what it would cost us. And that's, again, that's actually not too bad. So in some sense, you know, you could technically go with that and it wouldn't be the worst thing in the world. But we'll see that we can actually do even better than this. Now, we may even be able to beat that 53 figure here. Let's just test it very quickly. Again, I don't want to spend a lot of time on this because we're not going to use the burn here, but let's just see maybe if we could even do this with outward instead of prograde, and the answer is no. I don't even have to do anything more. We can see here we've already put in negative 62, and the closest approach isn't coming down, so no. The best way to do that burn, if we were going to do it at this point, would be to use that little bit of plane change and then that prograde. So now we know. So let's turn maneuver mode off, and let's consider then an alternative to when to do the burn. And how do we know? If not here, because this makes for a convenient point of reference when that gravitational influence drops in the stages update. That's a really good point of reference to know when to do a mid-course correction. Otherwise, how are you going to know when to do it? Well, the answer, conveniently, is also given to us here in TransX. And it's the first one is this line of nodes. As we're leaving Venus and we come around, the sun on our way back to Earth, and remember, we're not going to get back to Earth until we're all the way over here, so we have to go around a long way. But the best time to do the first mid-course correction is going to be when we cross this line of nodes, so it's a very good point of reference. Now, if you just use TransX to warp time forward, it's not completely clear when you're exactly at that point. So what I like to do is to bring up a line plane, and we have the sun referenced, and if not, then you need to reference the sun just by hitting reference, in sun. And then we're going to target Earth. And here, this gives us an actual number, timed node. So here we can actually see exactly when we're going to get to this point. Let's warp time forward, and you'll see what I mean here. Let's go to 1,000. Let's go to 10,000. And you can see that counting down. And also interesting to note is we are going forward. The closest approach is coming down. So that's also, that correlates to what we said the first time when we left Earth and headed to Venus. We were going to wait for the closest approach to get to its lowest point before doing the mid-course correction. I think we're doing something similar here, but more importantly than the closest approach in this case is when we get to the line of nodes. And again, we can just watch that number here, so we can bump forward, kill rotate. Actually, let me do one thing. I've disabled my kill rotation add-on that I have, so let me rotate toward the sun prograde. And that'll keep the vessel, I believe, from spinning all over the place. So we're at that point. Let me just get the vessel in position. So with the HUD set to orbit sun, if you rotate the vessel basically to prograde and then hit kill rotate when you warp time forward, it shouldn't spin out of control as badly. Okay, now let's go to 100,000. Staying a little bit on that center line at least. I do have a plugin that completely eliminates all angular momentum, but I'm just trying to see if I can do this method instead. So closest approach still coming down, but more importantly, again, we're just watching as we get here to the line of nodes. And instead of just using TransX to eyeball it, we have a line plane MFD over here that lets us know exactly when we're going to be at that point. And we're going to get all the way down, to where we're just a few hundred seconds away. So we're getting pretty close. Let's not terribly overshoot, so we'll back off. Then when we get down to 10,000, we'll back off again. And about right there. There we go. It's very easy to overshoot when you get stuck in that mode of going, warping time forward at 10,000 and such. So here we are, right where we need to be. We're still 3 minutes, or rather close to 5 minutes away. That'll give us enough time to set this up. So let's bring up TransX on this side, view the encounter. And let's see what the maneuver will cost now, noting that we're now at 1 gigameter on our closest approach as opposed to 6 gigameters. And there's actually two things I want to show at this point. Let's turn maneuver mode on, and the first thing we'll do is the wrong way of setting up the maneuver. And it's going to be very expensive, and you're going to think, oh my gosh, you screwed up, and you should have done it way back here. So let's go to prograde first of all. And let's just put in what we need to put in to bring that down. And you can see that with just -5, we're already very close. So let's go to a finer setting here. And there we are, just at so just with -11 prograde versus 53, we've already got our minimum altitude down to 15,000 kilometers. Of course, you're thinking that's not good enough because before we were all the way down to 200 kilometers. So let's go ahead and do that as well. Let's put in the plane change that we need to bring it down the rest of the way. And this is where you're going to think I screwed up, because you're going to see how much this is going to cost. So in order to bring down the plane change, we need negative plane, because if I put in positive, it's erasing it. So there, we'll go that way. We're already at -72. And I'm just gonna go ahead and play around with these a little bit to bring it down as much as I can at this point, because I just want to show what the problem is. So just bear with me here. Okay, that's down a bit. Down a bit that way. Down a bit that way. And I guess I won't mess with this all the way because it'll take a while. But the point here, you can see, as I go back and forth, I'm bringing this down, you know, a few hundred kilometers at a time. But it's costing us 192 meters a second, and that's way more than the 53.72 that we saw before. So it would be really easy to think that we messed up and we need to start the scenario back over at Venus and do the mid-course correction at the other point. But that's not what we need to do. What we need to do here is just get rid of the plane change. So we're just not even going to do it. Let's reset. So instead of having 192 meters a second, we're just going to put in just enough prograde to bring down the minimum altitude as low as it'll go at this point. And that is right about here at 15.82. And then what we're going to do is, for the plane change portion of it, there's another point in the orbit where we can do that part of the maneuver, and it won't cost very much at all. It'll just be 2 or 3 meters a second. So if we add this number, you know, 11, let's call it 12 meters a second, plus the additional maneuver that we're going to do in a little bit, it's still going to be way less than the 53 meters a second that it was going to cost us over here after we left Venus, you know, and the stage is updated. So let me just prove it and finish this maneuver. Let's go to do an update here, and we won't worry about the timing as far as, you know, bumping the date forward, and I'll show why. Because what we're going to do is come over to view target,
translation, rotation,
and we're going to rotate our vessel to get to that point, and then we're just going to turn the maneuver off. I do not see the green X. Ah, there it is. Let's just get the vessel rotated. Actually, I guess I should have known, because this is prograde, we could have really just used the prograde button, although I don't really like to do that anymore because those autopilots use more fuel generally than we do if we just press, you know, one touch of rotation and use 10x to speed things up. But we are here in this position. What we could actually do, if we want, is we could just burn down to the point where we've only got like 1 meter a second left, and I often do that, and then I'll turn maneuver mode off. But what we'll do here, since this is a fairly small number, is we'll go ahead and turn maneuver mode off now. And this is why we didn't need to worry about the date, because since maneuver mode's off, you know, obviously we're not using the maneuver, so it doesn't matter. But now all of our information's gone, and you think that could be a problem.
Translation.
But it's really not. Since we know we're facing the right way, all we have to do is now just put in a bit of translation and just keep an eye on view and counter. And we can also see over here the closest approach is coming down. And we know that this is 11.6 meters a second. Actually, I should have wrote it down before I turned maneuver mode off, but that's okay. So I know I'm facing the right direction because I set up the maneuver and I used view target to get the vessel in position. So all I have to do is burn forward, straight forward, and we're all set. And I probably could have used a little bit of main engine for this to speed it up, but that's okay. As soon as this is over, I'm going to make a note of what the maneuver mode said this was going to be, DV-wise. Okay, remember it was 15.82, so let's not overshoot, because that would be wasting fuel. Let's get down to the lowest point. Right there. Okay, so again, that was 11.6. And that was the line of nodes burn. Now, when do we need to do the next maneuver? Take a sip of water. This is water, by the way, it's not soda. So the next time that we have a really good indicator of when to do a maneuver, a really good reference point, is when we get to the point in our orbit around the sun when our vessel is traveling as slow as it can be. And we know that that's apoapsis. When you're at apoapsis, you're at the farthest point from the reference body, and that's when you're going as slow as you can be. And there's several things that we can reference to figure that out. Right here on the HUD, we have orbit sun. We could watch our orbital speed and go forward until it started, count. It's going to continue to count down as we go forward, and then it's going to bottom out and it'll start counting up. But we can also just clearly see here in Transx that apoapsis is over here. But the best way, undoubtedly, is just to bring up orbit MFD and reference the sum, which we can get to just by auto reference. And then we want projection ship. Distance doesn't really matter. Frame doesn't matter. And then we want to just watch our time to apoapsis. So we're here, and we want to go forward over to that point. And this gives us a good number to count down. And that way we don't have to just eyeball it or guess, or we don't have to look at, when that's counting down.
Rotation.
So I'm going to warp time forward now to get over to that point. And you can see the orbital speed going down. And if I didn't mention it, I want to thank Dimitri again for telling me about these 2 points. It did dawn on me at one point that using apoapsis would make a lot of sense, but I don't think I ever thought about using the line of nodes as a good reference for when to do these mid-course corrections. So again, big thanks to him. When I was, I think it was when I was doing this video, I asked him a couple of questions and he pointed out, do your first mid-course correction at the line of nodes and the second one at apoapsis, and I gave it a shot. Saw that it was definitely the best way to go. So again, thanks to Dimitri. So 100,000, we're still going forward. Just watching the time to apoapsis, we still got a ways to go. And we can see here where we're at in our orbit around the sun. And our orbital speed continues to go down. And interesting to see that our closest approach is coming down as well. Well, it was, now it's going up, but I believe it goes back and forth. And I think the reason it actually goes back and forth is because the moon is sort of tugging on the Earth a little bit. So we have that bit of a wobble. Now you can see it's going down. We're not too far away. Let's not overshoot. Although it wouldn't matter if we were just a little bit beyond it, but let's not overshoot. So 9876. Okay, let's back down. Let's back down again so we don't overshoot. Better to be patient than to run the risk of missing your targets. Okay, so we're only 800 seconds away, which means we are, for all intents and purposes, in this large of an orbit, we are at apoapsis. Orbital speed is as low as it's going to get. So let's go ahead then and bring up transx on this side, view the encounter, and let's see what it'll cost here to set this up. If we remember back at the line of nodes, in order to do the plane change portion of it, was costing us, 200 meters a second. It was really high, and we weren't even close. It may have been 1,000 meters a second or more, because we never did figure it out all the way. We just saw that it wasn't working out. But we'll go ahead and turn maneuver mode on here and go through the variables. And let's go ahead and start with prograde and just see what happens. Go to super setting. So we're adding in a bit of prograde, and we're all the way down. We're actually down a little too far. I don't think we necessarily want to cut the Earth down the middle at this point. We're getting to the point in our orbit now where our projections are getting accurate enough that I don't think we necessarily want to go all the way to the middle anymore. So here that's saying that that's going to be 9 meters a second to get the rest of it, So instead of that huge plane change over here, if we just do a little bit more prograde here, now that we're at apoapsis, we're only going to be at 9 meters a second. But I don't know that that's necessarily the best solution, so let's reset. And let's see if one of the other variables treats us better. Let's go plane change, because we skipped plane change here. So let's see if plane change is the right thing to do at this point. And I would say no, because we can see that as we're adding in, positive plane change, it's just raising the minimum altitude, and as we put in negative, brings things down a bit. Maybe if we use a combination of plane change and prograde, we can get the very best. Let's find out. So let's just put in enough plane change to get this number as low as it'll go, which is about right there. Sometimes a combination of variables is better than just using one variable, so we'll see. Okay, we're only at 8. Now we're adding in plane change, which means we're actually taking away the cost, because this is positive. It was negative before, and we're adding back in some plane change, so we're actually eliminating some of the cost here. So now we're down to 7.5. And of course we could just go with the 9 that it was costing us on the prograde, but why not be, why not save all the fuel we can? So that's 8.2, and I'm going to say that's probably as good as that will get. I don't think putting outward in would save us anything. So let's go ahead and just do that. 8.241, and this is the, just call it the APA. APA burn, and we'll do the same thing we did before. Rather than going through the maneuver and, you know, fussing, setting the date forward, we'll just view the target.
Translation. Rotation.
To get ourselves lined up. And as usual, I went the wrong way. So it flips around and now it has to go out the other way. Okay. And just to show the difference, what I'll do this time, instead of turning maneuver mode off right away, is I'll go to translation, and I'll burn until the delta V is down to just 1 meter a second or thereabout. That way we can see the number count down. Then I'll turn maneuver mode off. About right there is good enough. Now we'll turn maneuver mode off. And we'll finish it up just by using
rotation,
translation, because we know we're still facing the right way. Either way you do it, I don't think it makes a difference, but sometimes when you have a burn that's going to be, you know, 60 meters a second, or, you know, especially if it's larger than that, I do like to keep view target up long enough to bring the number down to where we're just within a meter or two. Now the only thing I'm debating here is exactly where I want my approach to be. Because as we go forward, there's still going to be a bit of transx inaccuracy, but I don't think at this point that I want to bring it, you know, like I said, all the way to the middle. I think we're accurate enough at this point that we can just have it really close. That's actually the wrong button. I didn't mean to do that at all. I think what I'll do is I'll just bring it down to, say, 1,000 meters below the surface. Yeah, we'll go with that. Okay, so that's our 2 burns. First one at the line of nodes was 11.6, and our second one there was basically 8.2, so about 20 meters a second to go from, you know, worth of mid-course corrections. And we'll probably have one more as we get in closer to the Earth, just to do a little bit of refinement. And I say one more, but it may be 2 or 3 more, but they should be small burns. And then as we get all the way up to Earth, then we may have one final bit of nudging that has to be done. This time went by quick, but it's already been 33 minutes, so I'm going to go ahead and end this part of the video here. I was actually thinking I'd go all the way to Earth, but I'm trying to keep these videos down to a reasonable amount of time. So that's going to be it for this part. Let's see here, I've got transx up, so let me Control S to save the scenario. And if you have any questions about what I did here, go ahead and leave your questions down below, comments, all that good stuff. And I will see you in the next part.